Okay, before we move on to the second part of lesson 5, we want to change this down here to L1. And then we're going to add a sheet. We're going to name this new sheet that I just inserted L2 completed. This is kind of an automated version of L1. And notice up here we have a drop-down menu for quarter pounder all the way down to Sunday. We have a drop-down menu for everything from quarter pounder down to cookies, right? And then over here, we've got some code inside this cell that says equal and then a string. This symbol here adds the stuff inside these quotation marks to whatever is inside of B1. B1 is currently quarter pounder. And this symbol adds to that everything inside these quotation marks. So you get the result looking like that. And then we've done something similar down here, right? Then over here, we have average. We're averaging the object with the name in this box. And so quarter pounder, no space, is everything below this word here, all these zeros and ones down here, right? So this, which refers to this word quarter pounder, this is the average of this column, which is 0.34. We do the same thing here, but the object named cookies, which is out here. That's 0.42. The average of this column out here is 0.42. So we've automated the process of calculating the lift. The support for the antecedent and the consequent, we're going to do the sum product of the object named quarter pounder and the object named cookies, and we're going to divide that by the count of the transaction numbers, the sample size. And then here, the conditional probability, cookies and quarter pounders divided by the probability of quarter pounder. And then here we're calculating the lift by taking what we just calculated and dividing by the other marginal probability. If I change this to chicken nuggets, and I can change this to chocolate shake, and I get a lift of 1.3889, which is exactly what I got earlier. So there's a way to automate this. Now, we can automate it in Excel, or we can automate it in Google Colab. Colab is a Python notebook that is available through Google account. I got this data set from this massive data set off the internet. It had 70,000 observations in it. So what I did is I created 20 of them. I created 20 subsets of them by randomly sampling 800 transactions from this much larger Excel spreadsheet. So it's gives everybody unique answers, and it increases engagement in this exercise. So the next thing we need to do is download this file, open it up. There is no column for the transaction number, right? This data comes from a bakery. It has 50 different products. Each of us are going to have a unique set of data, and we're going to have between 800 and 900 randomly sampled transactions from the original data set that I found on the internet that contained, I think, over 80,000 transactions. Now, 80,000 transactions would have been too much for this exercise. And plus, I wanted to make a unique experience for each student. Now what we want to do is we want to type this code into Google Colab. We're going to Google Colab, click on Google Colab. If it prompts you to sign in, then you'll need to use your Gmail account. Click on New Notebook. And then you can close this over here. you want to click on the file here and you want to upload this data set after you download it. So you click on that, you download it. Mine is in the download folder. Association mining underscore x7.csv. What I want to do is I want to upload it. I'll click on download here. And then there's my downloaded file. And you can see that it's been uploaded right here, right? Okay, so the next thing you want to do is you want to type this code as you see it. You can't copy and paste it. You have to type it. And that's the thing about learning new computer language. It's important to type it out. When you're typing it, you're learning it rather than just copying and pasting. I'm going to put you on pause while I type. Welcome back. I've typed the code out as it's shown in the screenshot over here. I'm going to cut it in two so you can see it in my screen here. So I've duplicated it. I'm going to keep the leverage, conviction, and an antecedent length there, but I'll delete everything to the square bracket. That way you can see everything. And then I've already deleted the leverage, conviction, and antecedent length. So now I'm going to delete the consequent length, the duplicates, and the Zhang's metric. That way it's nice and compact, right? So I've basically split this line here in two. And you can see my file here, association mining underscore ex7.csv. Now my code says ex2. Go down here and copy path. And then you can put the path inside the quotation marks. When you click this play button, it'll run the code. It doesn't look like it, but it did do a bunch of stuff. It did it rather quickly. This right here is a file that it created to output the lift values that we computed in Excel in the first part of lesson 5. Now, what we may want to do is we may want to put /content in front of this, and then it should show up right here. So if we run it again, you'll see. There it is, right there. That's the file that we created. Now we can download to look at it. Okay, so what we have the carts, we have raspberry cookie, we have lemonade, we have the support for the antecedent, we have the consequent support, we have the support for both, which is the joint probability, we have the confidence, and we have the lift. So that's the output of this algorithm. Now we can view that in Google Colab. We can type ASSOC and then run that, and we'll see it down here. This is exactly what we just downloaded, right? So I'm going to move this over here. I'll get rid of that temporarily. We got carts, antecedents, consequence, antecedent support, consequent support, the joint probabilities, the support of both the antecedent and the consequent, the confidence, which are conditional probabilities, and the lift. We sorted on lift, ascending, false. So we're going from the highest down to the lowest. Now we're going to go through the code line by line. I'm going to move this up one row. These two rows import tools that are used down here. We're defining baskets by using this tool read.csv that's in the pandas library, which is a toolbox. So that's the pandas toolbox. We named it PD. We're going to use this tool in that toolbox. to convert this thing that we uploaded to Google Colab. It was a bunch of ones and zeros below names of products. So in Excel, the names are in row 1, and the yes, no's, zeros, ones are below each column name. This transaction didn't include chocolate cake. Did it include lemon cake? It did include Napoleon cake. This transaction included apple tarts, right? So the names in this Excel file are in the first row. And whether or not the person purchased these products are coded as zeros and ones in each corresponding column. So what this is going to do is it's going to read this file and then save it as the Python object baskets. Now to view baskets, to view it in Colab or Python, we can type baskets at the end. Notice it's a data frame, and then press play. So this looks exactly like what we were viewing in Excel. Chocolate is not in a row of this data frame, this pandas data frame. These are the names of each one of these columns, right? Now notice the first row is identified as row 0. And the last row is identified as row 875. Down here it says there's 876 rows. So in Python, the first row is named 0, the second row is named 1, et cetera, et cetera, et cetera, right? So this is 875 plus this first row, that's 876. And there's 50 columns, as I mentioned earlier, right? So now let's look at what carts is. Carts is a data frame as well, right? So I'm going to move this up, I'm going to move this down. Carts is going to use the tool a priori, which was imported into this notebook right here, right? It and association rules were imported from this toolbox. ML meaning machine learning, right? So we're going to apply, in this line of code, we're going to apply the function a priori to this object we just defined as baskets. And then we're setting the minimum support at 0.005. And we want to keep the column names. I want to keep the column names. So let's go ahead and hit run right here and see what happens. So now notice that the column names show up in this second column. And this thing called support shows up in the first column. And this is the first row, but it's named 0. This is the second row, but it's named 1. The final row is named 393, and there's 395 total rows because the first row, again, is named 0, right? So we've kind of rotated that baskets so that the names of the columns in baskets become part of a column, right? The second column of this thing called carts. Now, where does this number come from? We can go back to the Excel file. I'm going to insert a row here. I'm going to type equal average. And then I'm going to highlight all the ones and zeros below chocolate cake. And I get a probability of 0.08333. So we got 4 3s there, right? And then if I drag this across, the probability of a single espresso is 0.05936. What's the minimum value? The minimum value down here is 0.02740, right? So this means setting the support at 0.005 means that none of these products here are going to be excluded. None of these products are going to be excluded because the minimum support, the minimum probability is 0.02740. So all 50 of these products will show up. Now above that row, I'm going to insert a row. And I'm going to start with column 0, column 1, column 2, because that's how Python would label these, right? So in this file object, in this Python object baskets, single espresso and the number 49 are synonyms. Same thing with chocolate and the number 0. They're synonyms, right? Because this is column 0, and that corresponds to chocolate cake. This is column 1, and that corresponds to lemon cake, right? So columns 0 in baskets was chocolate cake. Row 0 in carts is chocolate cake. Row 1 is lemon cake. Row 2 is casino cake. See how it's working? So what we can do now is we can look at each row separately. So I'm going to type LOC bracket and then 0 and then comma colon and hit run. Okay, so what this gives me is the probability that chocolate cake shows up in the transactions that I have, right? This is also known as the support. If I do 49 and hit run, I get single espresso and that probability. So let's open up, this is baskets, right? This is how baskets is defined. This highlighted part down here, I'm going to color it, I don't know, blue. This blue thing is baskets in Python, right? So if I go out here to the last column single espresso and 49, the probability is 0.05936. Right there, right? What if I go to carts and row 50? What am I going to see? Now I have casino cake and chocolate cake. Well, how does a priori calculate that number? Some rows here. I'm going to copy casino cake and chocolate cake. I got casino cake here, and I got chocolate cake here. All I'm going to do here is I'm going to do the sum product. Kind of like we did in the first part of lesson 5. I'm going to get the casino cake, which is right here, comma, the chocolate cake. Now I have 36 of them, right? 36 transactions of all the transactions, and each row is a different transaction, right? There are 36 with casino cake and chocolate cake. Now to get the probability, I have to do what? I have to divide by the count of one of the rows, right? So I'll just use the chocolate cake row. That's just the sample size, right? So for chocolate cake and casino cake, if that is the antecedent, then the probability would be what? 0.041096. That number. See how that works? And then maybe we can go out to like, I don't know, 150. Let's see what happens at 150. Now we have cheese croissant and vanilla eclair. So now we got a probability of what? We got to do the sum product of vanilla eclair and cheese croissant. And we got to divide that by the sample size. And we get a probability of 0.006849 there. See how that works? And we go further out. Let's go to 250. See what happens. Now we got lemon tart chocolate toffee. Okay, that's fine. 450. How about 400? All right, we got to find out what the last row was, right? I'm going to put a hashtag in front of this period, and that'll output carts. And our last row is 393 because we have 394 rows. So let's do this. 393. Got to get rid of the hashtag. Now in row 393, which is actually row 394, you have some products in here, but you don't know all the products because of this ... So one way to get around that and see what's in here is we can, underneath this line of code, we can write carts. And so this is row 0. So this right here is an object, right? It has 2 rows. Row 1, which is named row 0 or support. And then row 2, which is actually row 1, named row 1. It's also named item sets. So what you can do is if you want to use the name of the row, you can put a bracket, and then inside those brackets, you can have quotation marks and then the name item sets. This is the row number, and this is the column name of the object carts. And so we'll hit run here. And we see green tea, lemon cookie, lemonade, lemon lemonade, raspberry cookie, and raspberry lemonade. What I'm going to do is I'm going to copy this to the Excel spreadsheet. And now we want to calculate the support for this antecedent, right? Let's do this. Let's make this easier. I'm going to do a Control H here. Find what space and replace it with no space. And then do the same thing here. Okay, then I'm going to name these ones and zeros, these columns of ones and zeros, the thing that's above it, right? So I'm going to go to formulas, create from selection, top row. Okay. So now this right here is named chocolate cake, right? This will make it much easier. This is named lemon cake, right? So what I can do now is I can type this. I can get rid of these, click on that, comma, click on that, comma, click on that, comma, click on that, comma, and then click on that. And then hit enter. I had to type indirect on A2, A3, A4, A5. I need indirect on A1 as well. Indirect is grabbing the green tea. Indirect A2 is grabbing lemon cookie. Indirect A3 is grabbing lemonade. Indirect 4 is grabbing raspberry cookie. And indirect 5 is grabbing raspberry lemonade. And we get a probability of 0.021689, which equals, if I change this to support and run it, I get 0.021689,477, right? If I put a hashtag in front of this and run it, you'll see it here too. This list is abbreviated, but that's the probability of it, right? Now, because these are all variants of this object called association, what I have to do here is I have to comment out. I have to put quotation marks, 3, at the beginning and at the end here. So 3 quotation marks tells Python to ignore everything here. So if I hit run, you can see that I'm still getting the output of carts.loc, right? I'm going to delete that. Now I want to output a soak to figure out what it's doing. So this is what a soak does. It gives you the antecedent, the consequent, the antecedent support, the consequent support, the joint probability, the support of both the conditional probability or confidence, the ratio of the confidence and the consequent support, the leverage, the conviction, and some other stuff. Those are probabilities. This is a ratio of probabilities. What does this line here do? Well, this is going to create a new column named antecedent. And in that column, you're going to put the length of X. So the best way to do this or figure it out is just press run. I got to widen this up. Let me close that. So the antecedent length here is 1. Why? Well, there's only one product listed there, right? If we go down here, there's 1. Let's sort this by length. So we're going to sort a soak by antecedent length, and we're going to choose descending. So let's push play. So why is this 4 here? This antecedent length is 4 because there are 1, 2, 3, and then there's a 4th product in the antecedent. Same thing's going to happen here, except we're going to get this new column called the consequent length. We're going to sort by consequent length instead. Hit run. And here we have, again, 4 things in the consequent. In this consequent, there's only one thing called the orange juice, right? All right, so let's move on to the next item and see what it does. We're going to redefine a soak. Basically, what's going on here is we've got this double equals. That's a Boolean comparison. So if length of the consequent is equal to 1, and the length of the antecedent is equal to 1, then those things are kept in a soak. So anything with something other than 1 and 1, all those are going to be dropped except for the ones with 1 and 1, right? So notice a soak now has 642 rows. When we run this line of code, we're going to see a minimum consequent length of 1, and the same thing for the antecedent length, right? So we're doing a very basic association mining here, looking at pairs of products. They come in for raspberry cookie. Do they leave with a raspberry lemonade? So let's run that. And it doesn't matter which one I sort on. And notice what happened. Now we only have 340 rows. The consequent length, 1 to 1, 1 to 1. We sorted on consequent length. Let's go back and sort on antecedent length. We'll hit run. And notice our maximum value and our minimum value are both 1, right? 340 rows. And all of our antecedents have 1 product, and all of our consequents have 1 product. All right, so let's see what this does. This creates a column named index. So it basically copies the index as a column name. And we're going to rename that carts. So we changed the name to carts. That's easy enough, right? Okay, what is this going to do? This is going to sort by lift, which is what this is doing down here, right? So I'm just going to get rid of that part. We're going to run that. This is sorting by lift here, right? So the antecedent and the consequent products with the highest lift in my data set are lemon, lemonade, raspberry cookie, and lemon lemonade. Notice these are copies of each other. They're redundant. This line of code here is going to create a new column called duplicates. We're going to sort it by duplicates. So we got this new column called duplicates, and we sorted it on duplicates, the smallest being 0 and the biggest being 0, right? Okay, so now what this does is the first time through, I is equal to 1. So this is 0, and this is 1. So we're in the 0 row of antecedents, and we're in the row named 1 in consequent. So we start here, And it says if they're equal, then we're going to replace duplicates with itself added to 1. Right? And then this does the same thing. Now it's looking crossways here, right? So the first set is going this way. The second set is going this way. And notice that duplicates is now sometimes 2, sometimes 1, sometimes 0, right? Get rid of the hashtag here. And I'm going to sort by duplicates. So the highest duplicate we have is 2, and the lowest duplicate we have is 0. What's the next thing we're going to do? This is going to keep any row in a soak where duplicates is not equal to 2. So if we run that, the 2s are going to disappear out here. So it's going to keep the rows where duplicates is 1 or 0. So this is going to drop leverage, conviction, and antecedent length. Okay, so now it's nice and clean. We got the antecedents, we got the consequence, we have the antecedent support, we have the consequent support, we have the support of both consequent and antecedent, we have the confidence, and we have the lift. And it's ordered from highest lift to lowest lift. And notice the lowest lift is at 1.03436. That is because up here, we defined that to be the case. Lift, minimum threshold 1. If we change this to 2, the lowest lift will be what? 2.047. So we'll change that back to 1. This final line of code is going to save it to this soak.csv file. With these names, I'm going to download this and open it. I'm going to copy it. And I'm going to paste it in the file that I named lesson unit 5. I'm going to paste this soak file, the contents of it, right here. I'm going to go back to my instructions. We've done all this above, right? We've done all that up there. We went through it line by line. Now we want to clean it up. So what we're going to do is we're going to do a Control H, and I'm going to find everything, every reference to frozen, set, parenthesis, school go bracket, single quotation mark. I'm going to paste that right there and then click Find All and then Replace All. Then I'm going to look for this. So I'm going to replace that with that. And I'm going to click this button to replace all. Now, if I double click divider between the columns, I can see that it's nice and clean there, right? Raspberry cookie, lemonade, etc. Right? I'm going to change the decimal places, and I'm going to format this whole thing as a table. So I'm going to highlight row containing the names and all the values below that. I'm going to go up here to home, format as table. I'm just going to pick one. Now it's formatted as a table. And the reason why you want to format as a table, because it makes like doing things like sorting the rows very easy. You can sort by carts, you sort by lift. Okay, what's the next thing we got to do? In cell I1, right here, in cell I1, I'm going to type P parentheses C line A close parenthesis. And that creates a new column in the table. And then in cell I2, I'm going to do this. I'm going to do F2. That is the probability of raspberry cookie and lemonade. That's the joint probability of these two, right? That's what that is, the joint probability. I'm going to divide that by D2. And D2 is the antecedent support. This is the probability of the consequent and the antecedent divided by the probability of the antecedent, which is the conditional probability, right? And notice that it calculates all the values, and this value is equal to confidence. So we're just verifying that this conditional probability is the confidence. Now we want to type in cell J1. I'll just go ahead and copy it from here and then paste it in J1. Now we're taking this conditional probability and we're dividing it by the other marginal probability, the consequent support. and we get the lift. So we're just verifying that lift is a ratio of probabilities, and we're verifying that confidence is a conditional probability, right? That's all we're doing there. In the CSV file you download at the top of this problem, insert an empty column to the right of column A, insert an empty row above the names of the products, type probability of purchase in cell A1, and type the following formula into cell B1. Insert a column left of the data and a column above the data. In cell A1, we're going to type probability of purchase. And then we're going to type this into, and that gives me the support for chocolate cake. Then I'm going to drag this across to single espresso. Reduce the number of decimal places to 4. Now we're going to use this file and the one we're going to turn in on Blackboard to answer these questions. The antecedent or consequent with the greatest support is what? So what we have to do is we first have to sort by consequent probability, largest to smallest. The consequent with the highest support is hot coffee. In my data set, right? Hot coffee. What about the antecedent? Is that true for the antecedent? Sort smallest to largest or largest to smallest. Hot coffee. The product with the highest probability of purchase, which one's got the highest probability? The highest probability is 1107, right? We're calculating the maximum here. 1107, where's that at? Well, mine happens to be right there, right? That's the maximum. And it is hot coffee. So I just verified that the probability of purchase is the support. The antecedent or consequent with the least support. So let's go back to the file that we're going to turn in. The product with the least support. Let's go smallest to largest. So I have almond tart has a antecedent support of 0.0274. And vanilla meringue has a support of 0.354. So this is, mine's almond tart, right? Mine is almond tart. Now let's go to the original data set we uploaded to Colab. We need to find the minimum, right? The minimum is 0.0274. Now, where is that? I'm looking at this thing right here as I'm moving across, right? Whoop, there we go. Almond tart. Again, we just verified that the support and the probability of being purchased are the same thing. The antecedent support or the consequent support of bottled water equals what? And I'm going to look at the antecedent, search for water here, and then hit OK. So bottled water has an antecedent support always of 0.0776. I'm going to select all again. I'm going to do the same thing for consequent. Water. Water doesn't show up as a consequent. 0.776. The probability of purchasing water, let's go back to the original one that I modified. We got to find water, so I'm going to do Control F and then type water. Find next. Bottled water has a probability of 0.0776. Now we're going to sort the table from highest lift to lowest lift. So we're going to sort. Let's make sure that our filters are cleared. We got all those. We got all those. Now we're going to click on lift, sort largest to smallest. Raspberry cookie and lemonade have the highest lift. Lemon lemonade. The support for these two products is 0.0251. The probability of randomly selected customers buying the antecedent product and the constant product during the same bakery visit equals, well, that's the 0.0251. The confidence of the antecedent is 0.4583. The probability of buying the consequent given one has also purchased the antecedent product, well, that's that column I computed, right? That's this. It's probably the consequent given that we purchased the antecedent already. It's the same as the confidence. Dividing the previous value, this value here, by the consequent support gives the product's lift, which equals sort the table from lowest lift to highest lift. So now we're going to go from lowest lift to highest lift. The products with the lowest lift are, in my case, hot coffee and blueberry Danish. The support for the two products equals what? This is the probability that that this and that are purchased in the same visit by the same customer. That's the joint probability. Those are the same. Those two things are the same. The confidence of the antecedent is 0.0515. The probability of buying the consequent product given one has also purchased the antecedent, that's what we calculated out here in column I, the probability of the consequent given that we purchased the antecedent already. Those two things are the same thing. Dividing the previous value, this value, by the probability of the consequent is the lift, and it equals 1.0034. Now what we want to do is we want to modify the Python code to generate an antecedent baskets with one or two types of products. So we're going to find this in our code and change the double equals 1 to less than or equal to 2. So I'm going to just copy that. I'm going to go back to Colab. I'm going to do a Control F, and it takes me right to what I'm looking for. And it says to change that first equal sign to less than, and the second one to 2. And now when we run it, we're getting antecedents that have 2 products in them and consequence with 1 product. Why? Because we did not change, we did not change the consequent. We still want to limit the consequent to 1 item, right? So all our consequents are going to have 1 item. Our antecedents are going to have 2 or 1 item. The cart with the greatest lift now has what? The last sort we did is by lift. There's no other sort. So the antecedent with this greatest lift is lemon cookie. That's antecedent item 1. Antecedent item 2 is lemon lemonade. And then the consequent is raspberry cookie. The lift of this shopping cart equals a whopping 17.42.